derivative of a product of functions. So let's y equals u times v. So these are two functions. That's why we say product. Product means times, u times v. But each function, u and v, is a function of x. So we can say where u and v are functions of x. So we always have 2 points when we work on things. So let's say for the first and the second point, we just want the difference between them, right? At this point here, we've got x, and then we have y, and then we have u, and then we have v. That's the first point. Then the second point is we got x plus delta x, which means we will have y plus delta y. As you can imagine, we will have u plus delta u and v plus delta v. And so now we can use that approach to work out the derivatives here. Okay, so because we're trying to find the y dx, where we're going is we're trying to find the y over the x. So therefore, if we start with y plus delta y, because that's the beginning, that would be, well, we're multiplying those two functions together. So that would be u plus delta u times v plus delta v, right? And most of the time we always do expansion. We need to take y to the other side. So we can do delta y equals u plus delta u times v plus delta v minus y. But y is uv. So we can say delta y equals u plus delta u times v plus delta v minus uv. So we need to expand this bit here. U times v is uv. U times delta v is plus u delta v. Delta u times v is plus v delta u. Delta u times delta v is plus delta u delta v minus uv. Now we can see that uv plus uv minus uv will cancel out, and then we're left with delta y. At the same time, we could divide both sides by delta x, because that's where we're going. Delta x over delta x over delta x over delta x. Delta y over delta x equals u delta v over delta x plus v delta u over delta x plus delta u delta v over delta x. So now we need to do in the limit. So in the limit, because whenever you only can use delta when you are bringing it to the point where they become so close together, those 2 points. These 2 points, you want them to be so close that the difference between them will be so small. That will be infinitesimal small. So in the limit, so we have to use a limit here, where delta x tends to 0, and therefore delta y over delta x would tend to dy over dx. That's the only time you can use dy dx. At the same time, we have delta u over delta x, we tend to du over dx. And we would have delta v over delta x. We also tend to dv over dx. We have left delta u, and you know that delta u we tend to 0 as delta x tends to small, because they're making them small, right? So the difference have to be small. That is small, that will be small, that will be small, that will be small. And now we need to put all this in back into here, which means instead of having delta y over delta x, now we have dy over dx equals u. Instead of having delta v over delta x, now we have dv over dx plus v. Instead of having delta u over delta x, now we have du over dx plus, now delta u here is 0, so that's 0 times dv over dx. 0 times dv over dx is 0. dy over dx equals u dv over dx plus v du over dx. And that's the formula we're going to use for the derivative of a product function. So if you have a product function, a quick example would be to differentiate if y equals x cubed dot sine x. We can then use this where we can say this is u and sine x is v, u, v. And we just apply that to here. So u is x cubed here, so that's, we just say, which implies that the y, the x, will be equal to u, which is x cubed, right? The v, if you differentiate sine x, you get cos x. So that will be times cos x. Now plus, because that's a plus here, v is sine x, so we put sine x there. If you differentiate the u dx, this is the u dx. If you differentiate that, that will be 3, it goes to the front. Because for differentiation, we're using the y, the x is n, x, n to power minus 1. So that's one of the formula for differentiation. When you have y equals x to the power of n. So if you have y equals x to the power of n, the y dx is n, x, n to the power minus 1. So we have to times it by 3 is n, so that'll be 3x, 3 minus 1 to the power of 3 minus 1 is 2. So that's the, and therefore the y, the x, will be x cubed, x squared is common from there. There's x cubed here, there's x squared here. So x squared is common, x squared, open bracket, x is left because x squared times x is x cubed. Cos x plus, I've got 3, so I'll put 3 there, sine x. And that's the answer for that. So that's the answer from the derivative of x cubed times sine x. So this is a product function. One function times another function, differentiating them, you have to use product rule. So this is called product rule. If I like to put it here, that's the product rule. So the product rule will be the y dx equals u dv dx plus v du dx. Remember, alphabetically, u comes before v. So the y dx equals u dv dx, then you go v du dx. That's how to remember. U comes before v. So u, then differentiate v, and then v, then differentiate u. And that's what that is. Make sure u and v in this case with respect to x, with respect to, they might be with respect to t, they might be with respect to t. It doesn't have to be just x. It could be there could be a function of x, t, or any